cover it. Okay, as I was saying, I don't have a handout. This is just 5.5 textbook examples. The question, I'm reading it from page 292, example 1. The height of a car in an above ground Ferris wheel, the turning of it can be modeled using the function height is equal to 20 sine pi t over 60 plus 25, where t is time in seconds. I am going to, the question itself is going to say, what is the, I'm going to say, instantaneous rate of change at t equals 10 seconds. Okay, that's going to be my question. But just as a fun exercise, if this was a Ferris wheel if this equation is describing a Ferris wheel, what are some things you can tell me about the physical characteristics of the Ferris wheel? What do you know about the Ferris wheel? If I were to draw this picture, this was the ground, okay, and this is me, and this is me being very, very happy, okay? What can you tell me about this Ferris wheel? Give me one.
It's 25 meters above the ground.
What is 25 meters?
The Ferris, oh, the center.
Ah. The axle of the entire Ferris wheel. Okay? So I'm going to do that. So if this was like my Ferris wheel and I was, lodged into the ground, the height of the center of that Ferris wheel is 25 meters. That is very similar to the midline of my curve. Good. What else do you know about this Ferris wheel? Looking back. Okay, no one else is putting their hand up. Go ahead.
It goes up by 20 meters and down by 20 meters.
So the amplitude, in this case, let's not talk about it as amplitude. Describe the physical aspects of it. What does 20 represent?
As high as it gets.
The radius.
Oh.
The radius of the circle, yes. Right? So this part right here, you can say that is 20. That's a little funny to draw it that way. So how about I just draw it vertically? Okay. 20, which means also going downwards is also 20. Lastly, what does that last little piece tell you about the Ferris wheel? Maybe I can rewrite it. How about that? What letter is that? AKDC? It's inside the function. It's a K. What does that mean?
How fast it goes through a full circle.
Yeah. K is pi over 60. And remember, the new period is equal to the old divided by K, which is 2 pi divided by pi over 60, which is the same as 2 pi multiplied by 60 over pi. Bam, bam, 120. But not 120 degrees, because we're dealing with time. The new period is 1 full revolution in 120 seconds. That's a pretty decently, either really, really fast, really slow, or a really big Ferris wheel. Going around, it takes 2 minutes to go through the entire thing. Okay, so just some fun facts, just a quick link to our transformations. I think it's really useful to, again, the box method and all that stuff. I don't know if that is going to be helpful to you when you do these designs, but so I think it's a lot easier to process. Anyways, IROC, time at 10 seconds. What you want to do is essentially calculate the IROC, which is, as you know, the difference in the y value over the difference in the x value. You can also rewrite this as, there's so many ways textbooks do it. I think what I did was I said, what is the f of x plus that little bit over the x plus that little bit minus minus the y value at x, and then there's the x. The difference in y and the difference in the x. So let's calculate it. What is the height at 10.001 seconds? So 20 sine pi over 60 times 10.001 plus 25. And someone could give me that answer. I also want to find the height when I am exactly at 10 seconds. And we are going to use our slope formula for that. I don't know what that is. Just go from there. Okay, pi divided by 60 times sine of the answer times 20 plus 25. Okay, I am getting a height of 35.0009 at that exact moment. And then pi divided by 6 sine of that times 20 plus 25. I get 35 meters exactly at 10 seconds. Therefore, the IROC is going to be 35.009 minus 35 divided by 10.001 minus 2 zeros is fine. So 3 decimal places, 0, 0. Oh, for the y. Yes, that's 3. So 0.0009. I get about there. At that exact point in time, my height is changing by a positive 0.9 meters per second, according to the units given by the question. Rate of change. Okay. And then, well, those are questions that give you the formula, will give you an equation, which is nice. Example 2 is a situation where they give you a data table, and you have to derive an equation from it. But using the box method, I'm hoping that that is not a difficult scenario. You ready? Here we go. For example 2, check it out. I'm going to write right on top of the textbook, not literally, but you know what I mean. This is example 2. They give you a table. And the first question says, hey, write a sine function to model the data. Well, that's not very nice, but there are some things we can pull out from it. Look very carefully and tell me what the maximum number is. Tell me what the minimum number is. And, you know, we can start from there. Because ultimately, what we want to do is calculate A, K, D, and C. What's the max? Yep. 22.4, and that is in July. Good. Or month number 7. 22.4. What's min? Negative, yep. Yeah, yeah. Negative 14. And that happens in January, right? Which is in month number 1. Yes.
Can we get A from that?
Huh?
Can we get A from maximum?
Yeah. So if that is my max and min, generally speaking, where's my midpoint? Yeah. Mid would be, yeah, exactly in the middle would be basically an average. So you can add those two together. You get, you said 4.2, sorry. 4.2, that's right. So with that, what does that tell you? That is going to be my C value. From 4.2, I go as high as 22.4. 4.2, I go as low as 14. That tells me that my amplitude is 18.2. Right? Next. Where do you want to start? Well, I don't know. Our maximum was at July. Our minimum is January. We're doing a sine curve. So how about we start graphing stuff out a little bit? My max, 22.4. Sorry, 22.4. My min, -14. My midpoint is 4.2. I guess you could do 0, but let's just keep it simple. Okay? January is the first month, so we can call it 1, right? And then it goes all the way to, let's see, it goes to 7. And then it goes through December, and then it goes back to January. So this is January, this is July, and then this is January again. Sorry, you didn't even see that. In January is my lowest point. Okay. And then if it repeats, I have another midpoint there. Nice dream. In July is my max. Starting to see it? Between January and July, I'm expecting to have a midpoint. So it's going to be 4. Between July and January, I'm expecting to have a midpoint, which is February, January, July, August, September, October. Add a 3, that's a 10. Right. And so it should be something like this. It would be nice if we do a cosine, but you have to do a sine. So how far do I shift? 4. Correct. What's my period? 12. So my shift to the right, my D value is going to be 4. What's my K? Well, K, if you remember, it's new divided by the old. The new is a 12, my old is 2 pi. So my K value is going to be 6 over pi. Oh, wait. Nope. Sorry. K is going to be old over new, based on our formula, sorry. That would be 2 pi over 12, that's going to be pi over 6. So putting those 4 together, we have ourselves A value is 18.2. My sine curve starts here, right? So sine of K value pi over 6, x, go to the right by 4, and then go up by 4.2. And then you can apply rate of change or whatnot using that equation. Sure. it would be nice if the question asked me for cosine, because you already know where the cosine starts. The question happened to ask for sine, so I'm going to pretend it starts here, which means I'm going to say that the curve has shifted 4 to the right. And my curve would finish here. Yes?
I think they asked the cosine because they said January was 1, but you need to shift it back only.
Yeah, because you set January to be 1, yes, it would still shift 1 to the right, but then it's upside down. It's reflected. So what you'd have to watch out for is a negative value. If you wanted to, you can imagine that a cosine curve actually begins here, or you can say that the cosine curve begins here. Either way is okay. So if you tell me that there is a shift to the left by a certain number of months, or if you say that there's a shift to the right by 7 months, I'm okay with either one. They are both correct. Okay. So 5.5, I think the biggest challenge might be using a data table to create an equation. But if I remember the grade 11 teachers doing the stuff last year, we did give you an assignment where there was like this a data table like that. I think it was an in-class assignment that you were allowed to take home using Desmos. No? Never mind. Any case, something like that. A question like this was given as like a project kind of thing, right? And then you're supposed to make the connections by doing it. But here's some review for that. It is almost 11:30, so I will stop this video. A lot was done today. As a quick recap, I think the biggest one is the sinusoidal or the trig function equations that you have to solve. And then rate of change, it's a quick review.